So the first understanding is the swap method. So swap method, you might be given it in this question, you are giving the swap method, but just to be on the safe side, it's very easy concept, and pseudocode is just 4 steps. So maybe if you memorize it, will make your life easier. So here, as you can see, you are giving the swap method in this question, but just to make sure that you guys understand, to get your head around how it works, as you can see in this visualized interpretation of the swap method, you will have variable a and b. So you define a temporary variable called temp. First, you pass the value from a to temp. Now a values has been saved somewhere else, so it's okay to be overwritten. That's why you can pass b to a. Now the value of b has been saved somewhere else, so it's okay to be overwritten. That's when you are passing back temp to b. That's basically it. So as you can see, temp equal a, and then a equal b, and then b equal temp, and that's the end of the swap. Now another second understanding, which is two-dimension array. So what do we mean by two-dimension array? Normally we mean by that we are referring to a table. So two-dimension array, because the rows is one dimension and the columns is another direction. Always, when you are referring to a two-dimension array, the first element you will be interpreting it or writing it as two indexes. So for example, 0 and 0, or 1 and 1, or 2 and 2. Always the first index refer to the rows and the second index refer to the column. Keep this in mind as a rule. Yeah, first one for the row and the second to the columns. And this is a one-dimension array, and this is a two-dimension array. So now here, let's go through this question. The question goes, the following method, swap, that's the name of the method. So swap a and b, so it receives two parameters a and b, is written to exchange the values of variables a and b. You are giving here the swap method. And there is another method called swap rows. So it receives the matrix and it receives another two variables. Yeah. So it swaps elements of two rows, row K and row L, right? In the two-dimension array mat. For example, this is the original matrix. And once you implement the swap rows, it will implement it in whatever you are passing to it. So what's happening here? You are passing the matrix, which is this table, and you are saying swap 1 with 4. So this is 1. As you can see, the value is 4 triple zeros. And then 4, this is the value 5, 0, minus 1, and 0. When you implement the swap method, they will swap. So the 5, 0, minus 1 will be in the first row, and in the fourth will be 4 triple zeros. All right, so just to see how it works. There is another understanding, it's important that you have it in mind, which is, clearly how selection sort works, because it's been mentioned explicitly in the question. So how does it work? Just as a recap, it places small values into sorted position. So move from beginning to the end of an array, but the actual sorted data is accumulating at the beginning of the array. So if you have this example of the array 5, 3, 4, 1, and 2, you start at the beginning. So you look at the minimum value. Consider the first value you see in the array is your minimum value because you haven't explored the rest. All right, so we put it in the front. So in this array, we start with 5, we compare it with 3. Now we know 3 is the minimum. So we continue comparing 3 now because 3 is smaller than 5. So we look at the next one, yeah, at the next index. So 3 and 4, still 3 is the smallest. So we compare 3 and 1, yeah. Now 1 is the smallest. So now we start using 1 to compare for the rest of the array. So we go 1, we compare 1 and 2, and 1 is the smallest. Now we've reached the end of the array. So 1 is the smallest. Then at that point, we swap 1 with 5. Yeah, so we started with 5 as the smallest, but when we went through the entire array, we find out that 1 is smallest, so we replace. So the first round of our array will go 1, 3, 4, 5, and 2. Yeah, and then when we are starting on the next round of the array, we skip 1 because we know it's already been sorted. So we start from 3. We compare 3 and 4, 3 and 5, 3 and 2, and so on. Now there is a very nice tool. It's an open source. You can look at it. So this is just very quick. It's called Visualago. It shows you almost all the algorithm visualized how it works. So we are in the selection sort. So we click on select, and if you click on sort, it gives you by default unsorted array, and it shows you how it works. So here start with 14 and 3. Now 3 because it's empty. Because it's smaller, so it compare with the other. Now 3 is here, and then now you look at the next one, and the next round you keep comparing it with the other. Yeah. and then it swap and continues like this. So as you can see, it's always, you don't look at the one sorted, you start from the following one, and then it's sorted. So you can have a look at this online tool, it's really good. And let's move back to our slides. So let's continue with the selection sort. The pseudocode stepwise, you start with store the first element as the smallest value, as we said. Then you compare this item to the next item in the array, all right, until you find smaller number. Remember, we are comparing the index, but we are looking at their value. If the smaller number is found, you designate that number, that smaller number, to the new minimum, and continue until end of the array. If the minimum is not the value index, you initially begin with swap two values, and then you repeat with the next element until the array is sorted. But we don't start with the first element. So if you want to interpret this pseudocode stepwise into the traditional pseudocode that you are expected to write it in the exam, so you start obviously with defining the method or the procedure. And we know that it needs to receive the array, obviously. So you need to loop through each element of the array, expect the last one. So for I from 0 to the length, the last one here, just because you always start from 0. So you remember, if you have an index of 10, that means you're starting from 0 to 9. So you know the index is 10, that's the length of it. That's why you have the length minus 1, yeah? So because you're always starting from 0. And then you assume the current index as the index of the smallest value seen so far. So we take always lowest equal I. As you can see, I starts from 0. So we consider the first element in the index is the lowest, or is the smallest. And then you compare the current element, which is I now, with the rest of the element in the array. So that's when you have another value, which is j, to go from I plus 1, because you don't want to start from I anymore, you want to start from the next element. Remember, that's what we've just discussed, to the length of the array. All right. If smaller element is found, something smaller than I, update the index of the smallest element. So here, if array of j now, remember j is the next element, is less than the array of the lowest, which we defined, then you take lowest equal j, and then end of the if statement and end of the for loop. Now swap the current element with the smallest element found. So if I does not equal the lowest, then you have the temporary variable to take the value of array of I, the index of I, and then you have the array of I, you take the array of I, you take the array of the lowest, which you have it already, and the array of the lowest equal temp. So that's basically the temp that we had discussed it earlier, the temp method. And then end of if statement. You can wrap this in a method, just you call it, and then you call it, so for example, swap method, or you can have it as a procedure. All right, and then you return the sorted array. So that is the selection sort. So let's have a look at, we continue with the exam question. A game consists of 4 rounds. In each round, player can score up to 100 points. The data about the game is sorted in alphabetical order of names and sorted alphabetical order of names and sorted in the memory as the follows. So we have a player table, round table, and total. So let's have a look here. We say where players is one dimension array, as you can see this one. Hold name of the players, and it is sorted alphabetically. Rounds, it is a 2-dimension array because as you can see it's a table, and the rounds holding player scores, and total is 1-dimension array holding the total scores. For example, player 1 is Boris, so as you can see here, the total number of points he scored is 180. So Boris is 1, so we look at 1 here as well, and it is 180. And this can be found in total 1. Boris scored 40 points in the first round, which can be found in round 1 and 0. So always when you are referring to a matrix 2-dimension array, as I said, the first element, the first value of the index refer to the row, and the second value refer to the columns. So here round, let's have a look at the round matrix or round table. 1, this is 1, yeah, and then 0, this is 0, so that's here we are. So when the rows and the columns, they intersect, the value you find it is the value you are looking for, and it is 40. The value sorted in round 1 and 2, so let's have a look at round, and then this is 1, and then this is 2, that's 50, which is correct, which means that Boris scored 50 points in the third round. So the question here, as you can see, the first question, state Paul's total score. So have a 2 minute, you can pause the video to see if you can find the answer yourself, but we'll walk through all of them together. The second question, say state where Hugo's score in the 4th round can be found. And then the third one, say all the data stored in memory should be sorted in ascending order of total score using selection sort. Construct an algorithm that will sort all the data in ascending order. In your solution, you should call method swap and swap rows given in part A and B. So let's dive in. Here, the first one. So Paul's total score. This is Paul, yeah. And as you can see, he is in the a third player. So when you are looking at any total score in the total table, you look at the third, and it's 105. So that's the answer. The second one, state where Hugo's score in the 4th round can be found. So remember the 4th round. So you start here 1, 2, 3, 4, yeah, and it's 90. All right, so that's how you look. That's the 4th round, and that's it is because you know this is the row refer to the player and the columns refer to the round. All right, so it's available because it tells you where. Please make sure you don't give the value only. You can say and it is 90, but make sure you are showing you're referring 2 and 3. So the rows and the columns, yeah, because it tells you where the score can be found for the 4th round.